Hi, as you could probably guess from the introduction, I'm David Tiede and I'm an expert in non-destructive evaluation, or NDE. This is my life was prepared to inform the specialist group a little about my personal life and work history. My father grew up with his brother on a wheat farm in Spokane, Washington. His father and mother were of German descent and came to America when they were forced out of Russia. My father was a ceramic engineer and worked 41 years for Owens Corning Fiberglass. He was quite an inventor with 20 patents to his credit. He was always bringing home interesting things from work. I remember samples of fiber optics and photosensitive glass way before they were commercially produced. My mother was the oldest of 8 children and grew up on a dairy farm near Columbus, Ohio. Her maiden name was Pence, and it turns out I'm distantly related to our congressman, Mike Pence. She was trained as a nurse but gave up on the career soon after seeing several people die on the operating table. I was born on October 19, 1943 in Newark, Ohio. When I was brought to my mother after birth, she said, "Take him away. He can't be mine. He has no nose." Here's a picture of me in a failed experiment. I was trying to stay up long enough to see Santa Claus when he arrived. While in high school, I had a rather large-scale and complete chemistry laboratory in the basement. I did my own glass blowing to make equipment for experiments. I purchased an oil immersion microscope from a retiring doctor and spent a large amount of time making slides and drawing things I saw. My father built a diamond saw and polishing wheel which I used to prepare thin sections of rock samples to view under polarized light in the microscope. In addition to science, I also enjoyed playing baseball. I once pitched a no-hit game, and basketball. I graduated in 6th place in a class of about 350 from Newark High School. I applied and was accepted at 3 colleges, Miami University, Caltech, and Case. I chose the lowest cost provider, majoring in physics at Miami University in Oxford, Ohio. I did well in school, getting all A's in physics and only a few B's overall, graduating cum laude and a member of Phi Beta Kappa and other honor societies. While at Miami, the school got its first mainframe computer and started a new department called Computer Science. Since the computer was in the basement of the physics building, I asked permission to use the machine. I taught myself Fortran, and the first program I wrote played chess. This was the start of a long career of using computer programs as a tool. I continued my studies in physics at the University of Illinois in Champaign-Urbana, Illinois, and Case Western Reserve in Cleveland, Ohio. While at Illinois, I bought a BMW motorcycle and rode quite a bit, including a camping trip to Expo 67 in Montreal, Canada. I had several summer work positions. At Newark Air Force Base Aerospace Guidance and Metrology Center, I learned how to calibrate NBS traceable, electrical, optical, dimensional, mass, force, pressure, and time standards. At Owens Corning Science and Technical Center in Granville, Ohio, I wrote a program to compute the raw materials needed for a given glass composition, which replaced a manual trial and error method, and developed NDE methods to measure material properties of glass fiber reinforced composites. At the Metal Science Department of Battelle Memorial Institute in Columbus, Ohio, I built an ultra-high vacuum system for a field ion microscope, collected data for vapor deposition studies, and wrote a program to compute the angle between various Miller indices, which was published as a reference book. While in college, I was constantly pursued by the draft board, nearly being drafted several times. I solved this problem by leaving school short of a PhD and taking a job with the military deferment. My first full-time job was developing new NDE methods for McDonnell Douglas Astronautics in Santa Monica, California. Besides using the standard NDE methods, I developed interferometric holography and acoustic emission methods for missile components. These were brand new methods back in 1969. In fact, I suggested to Hal Dunnigan during a visit to Lawrence Livermore, where he was a researcher, that it would be nice if someone could commercially produce acoustic emission equipment. I subsequently purchased from Dunnigan Research the very first acoustic emission system ever sold. I used this system for the usual application, crack detection and location during pressure-proof testing of pressure vessels. I also used the equipment for unusual applications, leak detection, mechanical signature analysis, and loose particle detection in electronics packaging. The loose particle, or PIN detection, turned into a military inspection requirement. I was also program manager for a NASA contract on NDE of the Thermal Protection System, or TPS, for the Space Shuttle, and a Maritime Administration contract to reduce the cost of NDT for ship hull welds. As a result of this work, I visited all the NASA and shipbuilding facilities in the United States. McDonnell Douglas lost the competition for the Space Shuttle to Rockwell International. As a result, I was the last of 22 people working in NDE to be laid off and ended up working for Rockwell International Space Division in Downey, California. It was a good thing, too, because there weren't any other jobs available for physicists at the time. My job was to assure the quality of the TPS for the Space Shuttle. I developed the following methods: real-time radiography for detecting voids in the ceramic tiles, microwave moisture detection for the tiles, acoustic emission detection of cracks at the bond line of the tiles, mutual inductance eddy current coils to measure the installed thickness of the tiles, Eddy current method to measure the oxidation erosion of the carbon-carbon composite leading edge. Dimensional metrology tools to measure the gap between tile and substrate and the step from tile to tile. Alcohol penetrant method to detect cracks in the glassy coating of the tiles, and many more. I've been all over the space shuttles while they were being fabricated at Palmdale, California, and have been at several of the first shuttle landings. I was a Space Division Quality Assurance Engineer of the Year in 1977. I was also awarded the coveted Silver Snoopy Award. This is a sterling silver pen of Snoopy dressed up like an astronaut, which has flown on the space shuttle, and which is awarded by an astronaut to less than 1% of the workforce for extraordinary achievement. My work in acoustic emission at both McDonnell Douglas and Rockwell International resulted in a lot of sales for Dunnigan Research. And Devco, a piezoelectric sensor manufacturer, acquired Dunnigan Research, and the new company was called Dunnigan & Devco. I joined this company and became Director of Research and Applications. In this position, I developed analysis software, invented sensors, presented short courses, and developed inspection methods for large structures. Some of the large structures included blowout preventers, pulp and paper digesters, buried pipelines, very large pressure vessels, nuclear reactors, offshore platforms, and bridges. On this 35-meter diameter natural gas pressure vessel in Japan, we detected and located a growing crack during pressure proof testing. I'd like to talk about this pressure proof test a little bit in detail. The vessel is huge. There are several people standing on top of the sphere. For scale, notice a truck parked down below. We worked in that truck 24 hours per day for 2 weeks while a bank of very large air compressors pressurized the tank. Before this test, all source location calculations were done assuming planar or cylindrical geometry and surface wave velocities. I developed a solution to source location on a sphere and an iterative method to fit the calculated location to the measured delta times. I also developed a method to automatically cluster multiple events together. These were firsts in acoustic emission and eventually made their way into products. There was a high degree of anxiety and urgency when a cluster of events was detected because we were essentially sitting right underneath a very large bomb. I worked in China for 2 months, training operators and installing acoustic emission systems. I traveled from Beijing to Mongolia by myself without an interpreter. Talk about a stranger in a strange land. That was me. While there, I got to see the Great Wall, Ming Tombs, Imperial City, Summer Palace, and many more interesting places. It was an amazing experience and worth its own video. In fact, I took a lot of video and stereo pictures while in China. Dunnigan & Devco was acquired by Physical Acoustics. Not wanting to move to New Jersey, I took the job of manager of the ND Group at Rockwell International at Rocky Flats, Colorado. This is where the physics package of nuclear weapons was produced. I am not allowed to tell you the details of what I did there, but the main objective was to keep the bomb from prematurely exploding, regardless of what might happen. I did get to use very nice X-ray, acoustic emission, eddy current, ultrasonic, and interferometric holography equipment. Yes, I have actually held bombs in my hands. They're amazingly small and are quite hot. If you don't believe me, just hold this for a moment. Oops. Rocky Flats was the most dangerous place I have ever worked. When I left, I had to lay for 2 days underneath very sensitive and large detectors to see if I had any plutonium inside me. Rocky Flats has since been demolished except for 2 or 3 buildings which were not too radioactive. Fortunately, I was offered a better job, to establish an NDE capability at Cummins. I am the corporate expert on non-destructive evaluation, responsible for developing and applying NDE methods to prevent and solve quality problems. I created the NDE laboratory and trained NDE technicians for routine NDE support. I've developed specialized software and numerous inspection machines for specific problems. I'm on call as needed for support of production problems. In conclusion, I'd like to echo some thoughts expressed by Tom Yanoshonis.
You learn very quickly that experience counts. You can have all the tools in the world, but if you don't have the experience or the understanding, you won't solve the problem. I feel fortunate, even yet today, that I've dealt with a lot of experts.